Hello students. So today we're actually introducing you into making salt. So we're looking at acid, base, and alkali. And our learning objective is to know the differences between acid, base, and alkali. And before we begin, please make sure you've got all your equipment with you. I've got your pen, your pencils, your ruler, your green pen. Please pause the video, and when you're ready, press play to continue. All right, let's begin. Now, what I want you to do now is to write down your learning objective, which is to know the differences between acid, base, and alkali. Again, you can pause the video to do this, and when you're ready, let's continue. So we've got a retrieval question here, and this is what it's asking you to do, okay? It's asking you to tell us what these acid symbols actually mean. One is labeled A, one is labeled B. What do you think it is? Also, like I said, today we're looking at acids. Can you actually think of an example of acid? I want you to write it down in your book somewhere because you're going to be marking it as we talk about it. So I'm going to give you roughly 1 to 2 minutes to actually carry out this task. Again, pause the video, and when you're ready, press play. All right, let's continue. So A is actually an irritant, okay? And B represents corrosive. All right. Now, the extension was asking about what the meaning of A, which is irritant. It pretty much means it can make your skin red or blister, and corrosive means it can attack and destroy living tissues, such as skin and eyes. So both of these things is something you do not want to experience. Trust me, it is so important, like we did talked about in our last lesson, to follow the lab safety rules and guidelines. Okay. Now, again, you can pause the video to mark your work, and if you're done, press play to continue. All right, moving on. Now, introduction to acid, alkali, and base. Like I said, our learning objective is to know the differences between acid, base, and alkali, or also to actually know the names and properties of some everyday acids, alkali, and bases, and lastly, to understand what pH scale is and the pH of some everyday acid, alkali, and bases. Okay, and these are our keywords for today: acid, alkali, base, acid symbols, irritants, and corrosive. Okay. Again, pause the video and write down these keywords. When you're ready, press play. All right, let's continue. Now, again, this is our success criteria. All right. And so what I want you to do now is, I know this is going to take a bit of time, so I'm going to give you 5 minutes to do that. I'd like you to drop this, but drop them and organize them into groups. We've done part of this last lesson, but I want you to attempt it, and let's see how much you can remember. Again, pause the video, take a 5 minutes, and actually draw it and organize it into groups. Okay, let's continue. I believe this is actually something you should have. Okay, as you can see, we've organized it into groups. That is an element made up of only one type of atom. That's a compound made up of 2 or more atoms, okay, or elements. And this is a mixture, okay? It is not chemically bonded together. All right, now let's move on. So we're going to be looking at this different things today, okay? We're going to be looking at grouping chemicals: acid, alkali, and bases. So let's start off with acid. Okay, now these are the names of the acid we've got right now that we know. Okay, these are the few. Of course, we've got more different types of acid, but these are some of the ones you need to know for now. Okay, so we've got hydrochloric acid, we've got nitric acid, sulfuric acid, phosphoric acid, carbonic acid, citric acid, which is in lemon juice, and ethanoic acid, which is basically vinegar. So what I'd like you to do is to pause the video, and I would like you to try and write down the formula. What do you think is the chemical formula? Again, when you're done, press play to continue. Okay, let's continue. Now, these are actually the chemical formulas of them. Again, this is when you're going to take the opportunity to actually use a green pen to actually write down the answers. Okay, this is what we call a responsive feedback, okay, because these are quite some important formula you need to know and also know as you carry on with your education journey. So write down the chemical formulas. Again, when you're ready, play the video to continue. All right, so these are the acids. Let's continue. Now, what I want you to do now is to actually complete the statement. These are the keywords you should use to complete the statement. Again, I'm going to give us about 6 minutes. Actually, we could do this under 3 minutes actually. So I'll give us about 3 minutes to actually write down the sentence, fill in the gap, and when we're ready, press play to continue. And again, you could take a bit longer because again, you can pause the video to continue. Okay, let's move on. So these are the answers. All acids contain hydrogen. That's one big observation you should know. Their names usually end in acid, which is important. Now, some common examples are hydrochloric acid, HCl, nitric acid, HNO3, lemon juice, which is called citric acid, and vinegar, which is ethanoic acid. All right. Again, give yourself a mark. If you get it right, put your final mark score. If you didn't get it right, use a green pen to correct your mistakes. All right, let's move on. Now, again, sulfuric acid for our extension question, and this is actually chemical formula for phosphoric acid. Now, these are some examples of basically the different acids we've got. Again, these are hydrochloric acid, we've got sulfuric acid and sulfuric acid. Well, two sulfuric acid we've got there. But what is quite important is to actually look at the symbols there, the acid symbols. You can see that some of them are irritant, some of them are really, really dangerous. Well, they're all dangerous to be honest. They're irritant and they're corrosive. Okay, so it is very important to understand that all acids are really dangerous and you have to be very, very careful when working with them. Now, well, I've told you now, the question now is, what acids are present in this? I'm sure I've already told you the answers, and I'm sure you could say that they are corrosive and they are actually irritant. All right. Now, moving on, let's look at different everyday products that have got acid in it. Now, acid actually tastes sour, okay? And they are corrosive as well, which is really interesting. So we've got things like lemon, orange, vinegar, hydrochloric acid or acid, which is diluted, nitric acid diluted, and sulfuric acid diluted. They are actually acidic. Obviously, we've got the everyday products, we've got the laboratory acid as well. Okay. Now, moving on. Now we've got what we call a pH scale. This is something that actually tells us whether something is acidic or not. All right. And this pH scale has got a number from 0 to 14, and we're going to be looking at how to actually define them. Now, from 0 to 6, we say is acidic. All right. 0 to 6 is telling us that it's acidic. Okay. Now, the pH scale of the other one is quite interesting as well. Okay. And what's quite interesting is from 8 to 14 is actually alkali. Okay. And the question is not asking us, so what's happening to 7? Now, 7 is actually neutral. And an example of something that is neutral is actually water. Water technically has a pH scale of 7. All right. Now, this leads on to what we're talking about today, alkali. These are examples of alkali. Sodium hydroxide, zinc hydroxide, sodium, potassium hydroxide, and lithium hydroxide. Again, like we attempted for the last one, I want you to try and write down the chemical formula of it. Again, pause the video. When you're ready, get your green pen and play. All right, let's continue. Now, again, it's so important for you to look at the similarities between this. Again, some of the everyday products for alkalis are bleach, soap, toothpaste, surprisingly, and baking powder. And this is the chemical formula of each of these particular alkali. Again, mark your work, pause the video, make corrections, and when you're ready, you press play. All right. Now, what I want you to do, I'm going to give us 5 minutes to actually complete the sentence, okay, and put in the missing words. All right, moving on. So these are actually our answers, okay? All alkali contains the word hydroxide or H. Some common examples found in the lab are sodium hydroxide, potassium hydroxide, and the names of these alkalis actually end in hydroxide. All right. So again, mark your work, make corrections to it. You can pause the video, and when you're done, press play to continue. All right, let's continue. So, alkalis. What do you think are these acids? What are they showing exactly? Now, what you can see then is the fact that it's very corrosive and it's actually dangerous to life as well. So it is so important that you dispose it properly, because obviously it could kill the animals in the sea if you dispose it wrongly. Okay, now these are some everyday products, alkali products we've got. Like I said, your normal soap, washing soap, is actually alkali. Surprisingly, your toothpaste is alkali. Your everyday soap is alkali. And these are some of the laboratory alkalis that we've got. Things like sodium hydroxide and ammonium hydroxide. Now, you can see the word DIL. That picture means it's been diluted with water. Okay? So it's not as concentrated as it should be. But some labs have got some that are really, really concentrated, very, very pure, and very, very dangerous. It's still dangerous either ways, and it's so important that you stay protective. Now, alkalis feel soapy and they are corrosive. That's something you need to know. Now, also important to remember that alkalis can just be as dangerous as an acid. So it's so important that you do not underestimate how dangerous it is. Now, we've talked about acid and alkali. Now we're going to talk about a few things, okay? Now, pH of above 7, what do you think that is? So from pH 8 and above, is that alkali or acid? Well, it's a base. It's an alkali. Okay, bases are also known as alkali. Okay, so from pH 8 to 14, they're known as alkali. Okay, and what's quite interesting about them is that they do dissolve in water. Okay, now for below, okay, so from 6 down below, they're actually acid as well. Okay, and they do not dissolve in water. This is something you need to know as well. Only a base can dissolve in water. And keywords is the word soluble and insoluble. Okay, those are the main keywords you need to know about this. Now, let's have a look at this. So the question is, what is the differences between bases and alkalis? Now, the table shows 2 examples of bases. Remember, bases is anything with a pH above 7. So I would like you to answer the question. Is it an alkali or is it a base? Or is it an acid? Sorry. Now, it's actually yes. Okay, sodium hydroxide, remember it's got that word of hydroxide. It is an alkali. Copper oxide, no, it is not an alkali. We know that already based on the clue because it cannot dissolve in water. Okay, but it is a base as well. Okay, so we can have bases, we can have base, but not all bases are necessarily alkali. Okay, that is a very, very important fact to know. Okay, we've got bases, but not all bases are alkali. Am I making sense? I hope you understand that. It's actually important for you to write that statement down. Again, pause the video to write it down. Now, this is your inch question for you to try and answer. Again, pause the video. When you're ready, press play. And again, our answer is actually B, D, and E, which is the right answer. Okay? So, an acid can have a pH of 0 to 6. Its name is usually N in acid, which is true. D, acid have a sour taste, and alkali feels soapy, which is true. And E, alkalis are bases that dissolve in water and they are soluble. So what we're going to do is we're actually going to do a part 2 of this video. And when we're done, and so once you finish watching this video, please, I would like you to move straight to watch the part 2 of this video. And I'll catch you in the part 2.